page 32. This is the chapter 6 closure. So question number 146 says, solve the system of equations using any method. So looking at questions A, B, and C, what method would you use to solve for A? Can you put your Chromebook away, please? You could use elimination on that one, but there's another method that might be easier based on the way it's written. Sorry, the pencil sharpener's going. I can hear it. Equal values method, yes. Why? Because both of them are already solved for y, okay? How about part B? What would be the easiest to use for part B? Elimination is correct. Gentlemen, can you not talk while I'm talking? Thank you. Why would we use elimination for part B? The y's are all ready to cancel out. Those y's have what we call opposite coefficients. Okay, part C, what would be easiest for part C? John? Substitution, because that first equation is already solved for x, we can take that expression and substitute it into the other equation. All right, so let's look at each of those. For part A, since they're both set equal to y, I'm going to take the first expression and set it equal to the second expression. Okay, I notice that there's variables on both sides. So I want to move them to the left. I just prefer my variable on the left. So I'm going to add 4x to both sides. In the same step, I'm going to subtract 7 from both sides. Okay? You can do that as 2 separate steps, but I think it's easy enough to do those 2 steps in the same step. 3x plus 4x is 7x.
Girls High School students and staff, today we are having
Question A, we are going to use the equal values method. So you're going to set the first expression equal to the second expression, add 4x to both sides so that you get the variable on the left side, and then in the same step, subtract 7 from both sides, and then 3x plus 4x is 7x, 21 minus 7 is 14, and then the inverse operation of multiplying by 7 is dividing by 7. So 7 goes into 14 2 times. That gets you your x variable. Then to get your y variable, you're going to take that 2 and plug it into either of these. I think the first one's slightly easier because it doesn't have a negative sign. But you could easily plug it into the second one. So I multiplied 3 times 2, which is 6, and then 6 plus 7 is 13. All right? Question B. I'm going to use the elimination method because I already have opposite coefficients. The y's cancel. I combine the 3x minus the x, which is 2x. The 17 minus 7, which is 10. Inverse operation of multiplying by 2 is dividing by 2. And 2 goes into 10 5 times. Then I took that 5 and I substituted it into the second equation. So it's negative x, so I wrote negative 5 instead of positive 5. Added 5 to both sides, so negative 7 plus 5 is 2. Part C, I used the substitution method because the first equation is already solved for x. So I plugged it into the second equation where the x was at, and then I distributed. 2 times 3y is 6y. 2 times negative 5 is negative 10. Bless you. Bring down the 12y, bring down the equals, bring down the negative 4. Then combine any like terms. So we've got a 6y and a 12y, which is 18y. Add the 10 to both sides. And then 6 over 18, I reduced it to 1/3. Okay? Then I plug the 1/3 back into the equation. 3 times 1/3 is 1, and 1 minus 5 is negative 4. Any questions on A, B, or C? All right, jumping down to question 147. Bob climbed down a ladder from his roof, while Roy climbed up another ladder next to Bob's ladder. Each ladder had 30 rungs. Their friend Jill recorded the following information about Bob and Roy. All right, so the first guy, Bob, is going down the ladder. So mathematically, you're going to say minus 2x. And that ladder has 30 rungs. He's starting at the top. So he's at 30. He's going to go down 2. Yeah, it's y equals. Then his friend Roy is climbing up the ladder. So he's starting at 0. Do I need to write 0?
No.
Not necessarily, but he's going to go up one rung at a time. So 1 times x. All right? Both of these equations are set equal to y, so I'm going to use the equal values method. I'm going to say that 1x equals 30 minus 2x. Add the 2x to both sides, which is 3x equals 30. So I divide by 30, and I get 10. Just so happens that they both equal 10, which means they're going to meet up at rung number 10 on that ladder. Right? Any questions on 147? All right, question 148. They want us to solve for the variable x. So for part A, we've got 6x minus 11 equals 4x plus 12. So I prefer my variable on the left. So I'm going to subtract 4x from both sides, and I'm going to add 11 to both sides. So 6x minus 4x is 2x, and 12 plus 11 is 23. Then I divided by 2, and I got 11.5. Part B, I see that big set of parentheses. That reminds me that I need to use the distributive property, so I drew my rainbows. 2 times 3x is 6x, and 2 times negative 5 is negative 10. Set my two sides equal to each other, subtract 6x from both sides, add 10 to both sides, and I end up with 0 equals 6. Does 0 equal 6? No, so you say no solution. All right, part C. I've got a binomial times a binomial, so I used my multiplier box. X times x is x squared, x times 4 is 4x, x times negative 3 is negative 3x, and negative 3 times 4 is negative 12. So I combined my two like terms and got my trinomial. X squared, these two combine to get 1x and the negative 12. When I set it equal to the other side, x squared plus 4, I notice that I have x squareds on both sides. So if I subtract that, I'm just left with an x. Add the 12 to both sides, so 4 plus 12 is 16. Any questions on A through C? No? All right. Here's D through F. All right. D, I have a fraction equal to a fraction, which is called a proportion. One way to solve a proportion is to do something called the cross product or cross multiplication. So I found out where the variable is at, and I went that direction first. So x times 10 is 10x. And then the other direction, I had 7 times 25, which I got 175. The inverse operation of multiplying by 10 is dividing by 10. That basically just moves your decimal point over. So 175 becomes 17.5. Right? Part E looks like it's super hard. Why? Look at all those fractions. Okay? But we know how to take care of fractions, right? We do what? Fraction busting, okay? So you want to look at all the fractions. We've got, look in the denominator. We have a 3 here and a 4 here. What do 3 and 4 go into evenly? 12. So I multiplied all of my terms by 12. Look at all those rainbows, right? So if I multiply 12 times 2/3, I know that 3 goes into 12 4 times, and then 4 times 2x is 8x. 12 times 3 is 36. Then when I multiply by 1/4, 4 goes into 12 3 times. 3 times 1x is 3x. And then 12 times negative 7 is negative 84. All right? From here, I want to get my variable on one side or the other. So I subtract the 3x from both sides, and I'm also going to subtract 36 from both sides. So 8x minus 3x is 5x, and negative 84 minus 36 more is negative 120. The inverse operation of multiplying by 5 is dividing by 5, and 5 goes into negative 120, negative 24 times. F has some fractions as well, but just one, so it's not as bad, and the only denominator is 3, so I multiply all the terms by 3. 3 times x is 3x, 3 times x over 3. So 3 goes into 3 once. 1 times x is just x. And 3 times 4 is 12. Then I only have 2 like terms on my left side, so I've got 3x plus 1x, which is 4x. The inverse operation of multiplying by 4 is dividing by 4, and 4 goes into 12 3 times. Any questions on D, E, or F? All right, let's look at question 149. Solve each equation for the indicated variable. So part A says they want us to solve for B. Right now we have T equals A N plus B. So you have to kind of look and say, what's happening to that B? Well, AN is being added. So the inverse operation is to subtract AN, and we end up with TA minus AN. Are those like terms? Are T and AN like terms? No, they're totally different variables. So you can't combine them. They have to stay separate. Part B, this time they want us to solve for Y. So if you find where the Y is at, the Y is being divided by 3, and A is being subtracted. So the inverse operation is to add A to both sides. Then the inverse operation of dividing by 3 is to multiply everything by 3. And then I just distributed 3 times B is 3B, and 3 times A is 3A. All right, part C says to solve for M. You have F equals MA. M is being multiplied by A, so the inverse operation is to divide by A. D is the same exact problem, but this time, instead of solving for M, now they want you to solve for A. So you divide by the other variable, M, and you get F over M. All right, I'm going to move this up. We'll see it in just a second. And then we're going to jump over to page 33. All right. Question 150 says Leo solved a system of equations by graphing. His graph is shown below. So the first thing they want us to do is to estimate the solution of the graph. So you come over to the graph and get a good look at it. You see that they're intersecting right there. That is halfway between 1 and 2 and halfway between 2 and 3. So my guess is 1.5, 2.5. Good guess, right? All right. Part B says, what is the equation of each line in the system? So this first line that's going up, it's crossing right here at positive 1. So I put a 1 where the y-intercept goes. And then the slope is up 1 over 1, up 1 over 1. So I put 1 over 1. The second line crosses the y-axis at positive 5. And then it's going down 2 over 1, down 2 over 1. So I wrote negative 2 over 1. Part C says, solve the system algebraically. How accurate was your estimate? All right, so I took the two equations and I did the equal values method because they were both already set equal to y. I took the two expressions and put an equal sign between them. So this one I just wrote as negative 2x plus 5, and this one I just wrote as x plus 1. Just simplified it a little. Because I had variables on both sides, I subtracted the x from both sides, and I subtracted 5 from both sides. So negative 2x minus x is negative 3x, and 1 minus 5 is negative 4. The inverse operation of multiplying by negative 3 is dividing by negative 3, so I got 1 and 1/3. How close is that to 1.5? Bless you. How close is 1 and 1/3 to 1.5? Pretty close, right? Then I took that 1 and 1/3 and I plugged it into the first equation, and I got 4/3 plus 1, which is 2 and 1/3. They want to know how close I was. Well, I was pretty darn close. I was off by a fraction. Okay. and it's kind of hard